We're going to study right triangle trigonometry. Trigonometry means triangle measure. So we're going to look at two triangles which are similar. By similar, we mean the same shape but not the same size necessarily. The angles, however, must be identical. So we'll make this a 30, 60, 90 triangle. And we'll make this one a 30, 60, 90 triangle. The angles add up to 180 degrees, and I made the angles be 30 and 60. It can be shown mathematically that we can make the side across from the 30 anything we want it to be. I'm going to use a 1 for simplicity. And then the hypotenuse is 2 times as big. And then the longer side is the square root of 3. If I look at the similar triangle, let's say it's 3 times bigger. So I'll make the smaller side be 3. I'll make the hypotenuse be 6, 3 times 2. And I'll make the longer side be 3 radical 3. So mathematicians started looking at the ratio of the sides. For example, they looked at the opposite side of the angle that they were interested in over the adjacent side, over the hypotenuse, I mean. So if we look at angle 30, for example, opposite the 30 is 1, and the hypotenuse, which is opposite the right angle, is 2. So that ratio would be 1 over 2. Well, in the larger triangle, the opposite side of the 30 degrees is 3, and the hypotenuse is 6, and that ratio reduces to be exactly the same. These ratios were extremely important to mathematicians, so they decided to name them. Opposite over hypotenuse ratio is called the sine, so I would write the sine of 30 degrees is equal to 1/2. Sine is abbreviated SIN, but we still say sine, we don't say sin, so you would talk about the sine of 30 degrees being 1/2. The second ratio is called the cosine, COSINE. And if I look at this cosine of 30 degrees, mathematicians defined it to be the length of the adjacent side over the hypotenuse. Well, if you look at the 30 degrees, adjacent means right next to, but we don't want to use the hypotenuse, so that would be the square root of 3 over 2. Cosine is abbreviated COS, and again, we would not say cos, we say cosine 30 even when we see that abbreviation. The last main trig function is called the tangent, and the tangent of an angle is defined to be the length of the opposite side over the length of the adjacent side. So in this case, the opposite side from 30 is 1. The side right next to the 30, not the hypotenuse, is the square root of 3. We can rationalize that, rationalize the denominator by multiplying by square root of 3 over square root of 3, and a more mathematically pleasing ratio would be the square root of 3 over the square root of 9 in the denominator, which is just 3. The sine, cosine, and tangent can be memorized using an acronym which we call SOHCAHTOA. So is S, which is sine, is opposite over hypotenuse, that's the SO part. Cosine is C, and that's adjacent over hypotenuse, so that's the SOHCA part. And then the TOA is tangent, which is opposite over adjacent. So it's called SOHCAHTOA. Some people write it like this. I usually write it as a fraction. SOHCAHTOA, like that. So given any right triangle, the first thing you want to do is identify your adjacent, opposite, and hypotenuse. So let's say we're working with this triangle right here, and for some reason we're interested in working with this angle. Maybe we're given the angle measurement. So from that angle, what I usually do is I identify the hypotenuse first, which is the side opposite the right angle, so that would be my hypotenuse. I mark O, A, and H inside the triangle to help me. Then I go opposite the angle that I'm given and mark that one next. And the last side, which is sometimes the most confusing, would be the adjacent side. So that would be O, A, and H for that particular triangle. Let's say for purposes of working with this that A has a measurement of 6 and O has a measurement of 7. Then using Pythagorean theorem, you would get square root of 58, which is the square root of 49 plus 9. Pythagorean theorem again says leg squared plus leg squared equals hypotenuse squared. So if I were going to call this angle T for trig, I would say the sine of angle T is equal to 7 over square root of 58, opposite over hypotenuse. I always write this at the top of every paper so that I don't have to keep trying to think about it. I can just look at my acronym and get it right. Make sure you spell it right. So, ka, toa. The cosine of angle T would be the adjacent side, which is 3, over the square root of 58. And then the tangent of angle T. The tangent of angle T would be opposite over adjacent, which would be 7 over 3. Again, if you have to rationalize the denominators, do so. Multiply by the radical, numerator and denominator, and you get 7 radical 58 over just the plain number 58. Same with the cosine, we would rationalize that denominator and get 3 radical 58 over 58. And then the tangent of angle T is 7/3, and that's fine. Do not write trig functions as mixed numbers. The reciprocals of these, the reciprocal of sine is called cosecant and is abbreviated CSC. The reciprocal of cosine is called secant and is abbreviated SEC. And the reciprocal of tangent is called cotangent.